Okay, so this video is about finding the gradient and y-intercept of our best fit line, right? So of course, when we are calculating gradient, we need the two coordinates. Okay, so for example, I'm using the coordinates that I have found just now, right, from the previous graph. Okay, so as you can see, it's 45.00, comma 1.8000. Then the second coordinate is 20.00, comma 0.89000 bracket. So I use this coordinate to find what is the gradient of my best fit line, right? So let me just write down. So 45.00, comma 1.8000. Again, the second coordinate is 20.00, comma 0.89 with 30 behind. Okay, so the first, second. Okay, so maybe I'll label the x1, x2 first. So x1 is this, y1 is this, then after that x2 is this, y2 is this. Okay, so using our so-called our Emaths calculation of the gradient, right, we can calculate the gradient of this thing. Right, so let me just put down. So y1 minus y2. You can also put y2 minus y1. Doesn't matter. Right, so y1 minus y2, right? Divide by x1 minus x2. Alright, so as you can see that the denominator and the numerator is about minus. So whenever we are dealing with minus, we must get the least dp. So for this is about 4 dp, right? The first one is 4. Let's do the top one. So this one is 4 dp. Then the blue color is your 5 dp. So the top I must give them in terms of 4 dp. So let me just calculate. Okay, so the top as you need to put down is 0.9100. So this is 4 dp, right? Okay, now we move on to the denominator. So is for this is also minus. So minus we follow the least dp. So this is 2 dp. This is also 2 dp. So nothing to choose, just put in terms of 2 dp. So 45 minus 20, you should get roughly 25.00. Alright, so after calculating your numerator and your denominator, right, now we are going to divide. So divide, we must follow the least SF. So this one is how many? 4SF. This one is also 4SF. So of course the answer I give must be 4SF. Of course you can put another, add one more SF, 5FS, SF. So let me calculate. Okay, so in the event I put in terms of 4SF is like this, 0.0364. But this is only 3SF, right? You put one more zero behind. Okay, so this will be the gradient. Of course, you can put 5SF, but that's not necessary. And not to forget one more very important thing about calculating your gradient. Please put your units down. So I'm plotting t square against your L, right? So your t square is second square, then your L is centimeter. So if you want to put your gradient units, you must put in terms of second square per centimeter. So either you can put in this form, or you want to be more sophisticated, you can put in this form, second square cm inverse 1. So either way, is both acceptable. Right, so this is how you calculate your gradient. So first of all, we must know that the minus, both this minus sign, we follow the least dp. Then after that, the final we need to divide. When we are dividing, we follow the least SF. Right. Okay, next we'll be finding the y-intercept of the best fit line. Okay, unless your graph is both your axis, x and y axis, start from 0, you cannot read your y-intercept directly. So in the event you are asked to find your y-intercept, what should you do? So if you want to find y-intercept, so for the example of this, right, t square equal to KL, right? Okay, so let's just say I just plus a C lah, right? So plus a C here. Okay, so for your K, we know the K itself is your gradient, right? So this is 0.03640. Then after that, your length and T square, we should sub in. So I just sub in any of the coordinates. So let's just say I sub in this coordinate. The first, the so-called the 45.00 and 1.8 with 30 behind. So I sub in to find my y-intercept. Okay, which is here. Then your t square is 1.8 with 30. Right, so so you just calculate. Okay, so first of all, you would deal with this and this. So you multiply, right? So multiply means you need to follow your least SF. So this one is 4SF, then this one is also 4SF, right? So the multiplication just give me 4SF. So 1.8000. Then after that, 0.0364. So 4SF is 1.638. Then after that, you plus a C. Okay, so you want to find the y-intercept, you simply just get y-intercept is equal to 1.8000 minus away your 1.638. Okay, so this one is minus already, so you must follow the least dp. Okay, so let's check out the dp first. So this will be 4 dp, this will be 3 dp, right? So of course the answer you must give is 3 dp. Okay, so 3 dp is just 0.162. Yeah, so this is your finding your y-intercept. So this is when your axis doesn't start from 0. So if I go back, right? If I go back, okay, so this graph you can see both my starting point is not 0. It's actually 0.8 and 10.0, right? So that's why I cannot read directly from your graph. If you start both your axis at 0, you can read directly. Yeah, so if you check out your 2019 O-level practical, actually there's one experiment where we start both the axis at 0 point origin. So that's why we can read the graph directly. So in order to read your graph directly, both these axes must start from 0. Let's just say one of the axes start from 0. So let's just say your x-axis start from 0, but your y-axis, I don't start from 0. Let's just say I start from same thing. I start at 0.8000. This one, you can also you can't read off directly. Okay, in order to read off directly, both must start at 0. If one of it doesn't start at 0 and one of it starts at 0, right, you still cannot read off directly. You need to sub, just like what I did just now, right? And give the y-intercept to the appropriate number of significant figure according to the SF and DP rules. Alright, so this is for the calculation of our y-intercept.